78% of the gases that you and I are breathing right now is either A, nitrogen, or B, oxygen. You have 3 seconds. Wrong. It's nitrogen. And that's the subject of our video today and the last macro in our series on macros. Yep, it's all about nitrogen. Let's get into it. In the early 1900s, two German scientists, Fritz Haber and Carl Bosch, tackled what was a very difficult chemistry project: how to take atmospheric nitrogen and sequester it into a usable form of ammonia. This was a revolutionary breakthrough that allowed humans to take an otherwise inaccessible form of nitrogen, convert it into a usable form of nitrogen, and it revolutionized the commercial agriculture across the planet. So why is it that the advent of the Haber-Bosch process in order to sequester nitrogen was so important? Why nitrogen? Why was that such an important part of developing agriculture at a commercial scale? Nitrogen is one of those macros, right? So the NPK that we've talked about for a long time now in many of our videos, N is the nitrogen of the macros. We've covered the P and the K in previous videos. Be sure to check those out. And make sure that you subscribe to the channel if you're interested in geeked out soil science stuff like this. The nitrogen that we are thinking about for plant development is not something that here at the farm we like to think of in urea, ammonium sulfate, or ammonium nitrates. We're really interested in the natural forming nitrates that are in that soil that can be sequestered by bacteria. And the magic of bacteria, and we've been talking about microbes for a long time now, is that they are able to do things that, frankly, we can't do without. The bacteria that are associated with legumes, peas and beans, are these incredible nitrogen sequestering bacteria. They're known as rhizobia. Rhizobia have this ability to take atmospheric nitrogen and convert it to nitrates or ammonium in the soil that then are directly assimilable by the plants. The other way that nitrogen makes its way into the soil naturally is simply through the natural decomposition of plants and animals. The two forms of nitrogen that we are focused on for plant health is nitrates and ammonium. NO3, a nitrate, is in that negatively charged anion form, and the NH4 in ammonium is a positively charged cation. Nitrates typically are much more mobile than ammonium, and it's where we tend to focus on our soil reports. And the way that we think about nitrogen in terms of its functionality for plants is really going to be in the form of three big areas. The first and most obvious is in the way that it sets up for chlorophyll. Chlorophyll is that magic green God molecule that everyone knows about, which is 4 nitrogen that are holding a magnesium ion in the center. Without the 4 nitrogen molecules in place, holding that magnesium ion in place, the photosynthetic magic that plants need to achieve is not possible. So nitrogen is essential in the formation of that chlorophyll in order for photosynthesis to occur. The second key role that nitrogen plays in plant development is in its relationship to proteins, to amino acids, to DNA, to RNA. The role that nitrogen plays in all of those protein synthesis compounds in the plants is essential. And the third and final key role that nitrogen plays is in the development of roots and in that synthesis of absorption, both in terms of nutrients as well as water. Without sufficient nitrogen, you just don't see an efficient and healthy root system which is able to process and cycle all of the nutrients and water properly. So now that we have a good overview of the history of the manufacturing of nitrogen, the way that atmospheric nitrogen is sequestered in the soil, and the different roles that nitrogen plays with plants, what are we doing with nitrogen here in our cultivation? How do we think about using different fertility products to support the nitrogen levels in the soil and to ensure that our plants have enough nitrogen? So there's a couple of different ways that we think about those different products and how we use those in our lineup. Some are liquid and some are dry. Most of these are a protein hydrolysate base. So a protein hydrolysate is simply broken down form of protein that is more in sort of the constituent components of amino acids. It makes the proteins and the amino acids more readily available. So the protein hydrolysate and the fish hydrolysate that we are working with have been sort of a staple for us in terms of a source of nitrates and nitrogen in our lineup. We use the fish hydrolysate, of course, which is a classic. I remember growing up and my dad using fish hydrolysate in the veggie gardens, and the gag when I was a kid was smelling the bottle. It's pretty putrid, but it's a beautiful product that has a gorgeous array of amino acids and nitrogen. And then the soybean hydrolysate that we use is in the form of the down-to-earth product that we've been using for quite a while called Agmino. This is an 1100 nitrogen product that is, again, a great stoke for the nitrogen levels in the soil, readily bioavailable, and one that we've leaned on for quite some time. Of course, our BE Plus has been a wonderful amino acid product as well. That's our good buddy Tay. Shout out BE Plus. Love that product. There's for members on the platform, we've got discount codes for that BE Plus. We are big fans of Tay's product. We've been using it for about a decade now. And the other nitrogen product that we have been beta testing is a 2100 product that is, again, early days. I'm not going to reveal the product yet because it's still in beta testing, but we do have another nitrogen product that we've been excited that we've been testing. And again, every single round of soil that we're using in our facility, we have soil tested through Logan Labs. We look at the nitrate levels, and then we make determinations as to what we want to bring to the party to either increase or simply manage those nitrogen levels to make sure that our plants have enough for that vegetative cycle. Hopefully this breakdown of nitrogen has given you guys an indication as to why this macronutrient is so important in your cultivation practice. If you haven't seen our other two videos on the other two macros, phosphorus and potassium, be sure to check those out in our library. If you have any questions about this video, be sure to post those to the comments below. Of course, be sure to subscribe, and we will see you on the next one. Let's cultivate.